Good evening, everybody. I'm Isla Berman, the Director of Architecture, for those of you that don't know me. It's with great pleasure that I'm able to welcome Mimi Hoang to CCA as our lecturer this evening. Mimi is a partner of N Architects, an award-winning firm in New York City. The work of the firm has been extensively published, most recently in a monograph on their work, elaborating 16 projects from 2000 to 2008 as part of the Design Document series. The firm has received widespread attention as a practice invested in generating intelligent and creative solutions across a wide range of scales and disciplines, from experimental exhibitions, interiors and buildings, to urban design and landscapes. The firm focuses on interpretive research stemming from the initial brief in each project and has gained a reputation for understanding the specificity of each in light of a larger generic context and representing these through a series of diagrammatic operations that expose and manipulate the variables put into play in each work. Unlike monofocused practices that pursue identity at the expense of complexity, and architects have been able to integrate complex hybridized programming with sophisticated materials and fabrication research, while also developing a wide range of environmental strategies that influence the morphological development of each architectural work. Projects such as Hotel Proforma and D Central Park operate at the micro and macro scales, creatively pushing programmatic limits into the realm of performative invention. Just as Canopy, designed and built for MoMA, PS1, and Windshape, a set of temporary pavilions in France, explore and amplify material properties and their sensorial effects. Their practice is responsive, intelligent, and highly strategic, always maximizing the ingenuity, impact, and operative effects of every design with minimal means. Their work has been recognized internationally with many awards, exhibitions, and publications in over 15 languages in the very short time of the firm's existence. Recent awards have included 2 AIA New York Design Honor Awards, an AIA New York Building Type Merit Award, the Architectural League of New York's Emerging Voices Award, the Canadian Professional Rome Prize, Architectural Records Design Vanguard, and of course the MoMA PS1 Young Architects Program. Mimi received her Master of Architecture in 1998 at Harvard University and her undergraduate architectural degree from MIT. She currently teaches at Columbia University and has been the Louis Kahn Visiting Professor at Yale University, was also a faculty member at Harvard, and the Friedman Visiting Professor at UC Berkeley. Please join me in welcoming Mimi Hoang this evening.
Thank you, Isla, very much for that introduction. It's a special honor for me to be here tonight because my mother actually attended the CCA in the 60s as a scholarship student from Vietnam. So, what are we really in control of? Can what we are not in control of be a positive thing? What is invisibly controlling us? The title of the lecture refers to a line of inquiry about the amount of control we have over our medium and the potential productivity of embracing indeterminacy. Is there a bit more light for the audience? I feel weird, I can't see any of you. I feel like I'm talking to a pitch black room. That's nice, thanks. To what extent do we control the outcome of our work through our tools of conception, representation, and fabrication? To what extent are we in fact controlled by them? Ultimately, our aim is to achieve a kind of richness and complexity of experience with an economy of concept and means. But we think that there's a prevailing obsession with means, and that sometimes this results in the reverse. A tyranny of tools and techniques is producing an increasing dullness, a flattening of architecture to the surface, an abdication not only of responsibility but possibly of opportunity. In the same way that you can recognize a building that is designed in CAD, one can see the trace of CAD-CAM in the proliferation of perforated surfaces and sectional arrays. We're guilty of the same thing. To some extent, this is unavoidable, and if framed correctly, it can be interesting. But is it possible that a majority of buildings and theoretical projects are largely controlled by the means of representation and construction, either unwittingly or due to a misplaced obsession? Are we answering the right questions when we design a project? As architects, we often rely on parameters that are given to us: program, typology, context, budget, etc. But are these parameters correctly framed? Is it sufficient agency for us to be opportunistic within a spectrum of information that we receive? How can we be more proactive in balancing control and indeterminacy in our work? I'm going to be showing 10 projects tonight, divided into 3 general categories that are really interdependent, but they're just general themes that pop up in our work. The first is users and amenities. The second is conceptual and material economy. And the third is the idea of using climate as a strategy. So, can a program control or predict the way that we use a building? Cultural identities are often too complex to be easily addressed in a shopping list of space type allocation. So we typically begin each project by questioning the programmatic script that we're given, by focusing instead on amenities that shape the end user's experience. So the first 3 projects explore an architecture that provides a specific but loose armature that allows users and what we call misusers to reconfigure relationships, and that could be social, spatial, or thermal. Party Wall was a commission by Artist Space, which is a gallery in New York. They commissioned us to do an installation. And so we immediately started by thinking of the gallery as a social site and wondered how could we create a community among strangers. We took the most basic architectural element, the wall, and wondered what if the acoustic or the optical properties were dynamic and responded to visitors. So it's as if we kind of unwrapped the enclosure of the wall and started messing with the inside. So our party wall, rather than dividing space, is a kind of instigator of exchange and dialogue. We worked with Parul Vora from the MIT Media Lab to do the programming and the hardware. And basically, this is a diagram of the wall. It's supported by hollow tubes, and clamped onto the tubes are a series of interactive infrared sensors that detect proximity. These in turn signal microprocessors that activate these servo motors that pull the bands of foam apart, creating sudden apertures in the wall. And we started by testing one sensor in our office and then eventually building this up. And so the construction logic is basically a shish kebab. All the pieces are laid out on the floor and then kind of, like a shish kebab, skewered into the hollow pipes, which carry all the electrical and data wiring. This is an example of one of those locations. And then the whole thing is tilted up and screwed into the ceiling. And this is a close-up of one of those servo motors that pull the bands of foam apart. And then the section on the right is kind of the at-rest state, and then the section on the left is when it detects your presence. So this version of Party Wall responds to proximity, but we really imagined it as a kind of prototype that would respond to heat or light or sound in other future iterations. Can we have sound? So what happened was, we're not really sure, but the wall never actually came to rest. And it was a bit scary. It was a little bit of a Frankenstein. We thought it might walk away out of the gallery. But we think that because the foam is soft, the movement of one motor kind of triggers the movement of another motor. So it took a while for it to come to rest. So it kind of assumed a kind of erratic life on its own. It wasn't actually totally controlled interactivity, something in between, which ultimately is what we liked. It kind of responded to external forces, and it was responding to itself. So it was predictable and a little bit unpredictable. The next project is continuing this idea of a loose armature that allows users to configure spatial relationships. Dune Terrace was a competition for an 800,000 square foot museum in Giza, Egypt. The permanent exhibitions are in that floating bar above, and then there are 5 lobby gates, and then the special exhibitions and everything else is below. So the location was right at the maybe half a mile away from the pyramids of Giza, and the brief described this very large daily visitorship of, I forget now, but we started to think of the museum as a kind of cultural portal to the other archaeological sites in the area. And we, this is the site plan, it's kind of on a plinth overlooking the pyramids. And we started to question the navigational determinacy of the typical museum circuit, which we felt was kind of monumentalizing circulation, that you always, enter at the lobby and you always circulate around. And so we asked, what are some possible alternatives to the conventional gallery sequence? So given the increasingly varied museum-going public and the volume and flow issues, we started to think about the airport, and we borrowed the airport model, which for us was a way to offer more varied and at the same time more precise trajectories into the museum. So the visitors arrive onto the Dune Terrace, which is this exterior plateau overlooking the pyramids. And in the spirit of airport departure gates, you can choose from 5 different lobby gates that will take you directly to a certain location in the exhibition. And you can go up or down depending on whether you want to go to the permanent collections above or to the special exhibitions below. And this is a sectional model slicing through one of those lobby gates. So in the Wunderkammer model of the museum, which is the top little diagram, the rooms vary in proportion, in height and in proportion according to the work displayed. Here in Dune Terrace, the galleries achieve this variety by modulating the floor. So in shifting the level of the floor, we wanted to kind of shift perception of the object and shift the vantage point to the desert beyond. You can kind of see in this image one of the floors dipping down. So rather than always being at the floor looking up, you're able to create multiple vantage points. This is the upper plan of the permanent lobbies, the permanent collections above. It's organized east to west chronologically, and intermittently there are these bands, the thin bands that we call concourses, which are where all the digital projections were. So ultimately we kind of saw this museum as a kind of a matrix of many possible routes and destinations that would offer everything from the traditional circuit, but also an easy overview where you can just kind of sample all the lobby gates, to random browsing to direct access. This is maybe 1/100th the size, but we're still working with the same ideas many years later. This is Endless Table, which is an exhibition design that we did for the Drawing Center in Soho. It was to exhibit Frederick Kiesler's drawings. Frederick Kiesler was an Austrian architect who immigrated to the States before World War II. He's most famous for his exhibition designs, actually, for the Peggy Guggenheim Art of the Century Gallery, where none of the walls were orthogonal, none of them were actually straight, and all of the paintings were kind of none of the paintings were parallel to the walls. He's also very famous for this house, which he worked on for most of his career, called the Endless House, which is very contemporary now. Philip Johnson labeled him the best-known non-building architect of our time. I don't know if that's a compliment or not. So we designed a 145-foot-long table, an endless table, that kind of collected all of his drawings in all the different fields that he was working in. For us, the challenge was to try to address his his salient ideas without aping him. And those are mainly the idea of endless space, the idea of co-realism, which he defined as the correlations between things are more important than the things themselves. And third, the idea that perception is a constantly mutable, changing construct. So this is the plan. It kind of snakes around the gallery, exhibiting all 70 drawings in this kind of endless loop winding around. And this shot of the security camera kind of gets at this idea of correlation between the viewer, the object, and the space. And actually, the Drawing Center, its mandate is to exhibit two-dimensional work. And for the first time, I think we didn't use any of the walls, because typically they only exhibit things in the walls. So the thing kind of unfolds and it winds its way around, and you cannot see all of the work all at once. You have to experience it in motion. We were really interested in, creating this kind of singular gesture, within a singular gesture, a great variety of perception of the work, a great variety of experiences. And then most of them fit within the table, most of the sketches. The larger ones are in these tilting panels. The larger they are, the more vertical the tilt is. And you see how smart we were to choose white, because everybody wears black at the opening, so it really popped out. And we were very interested in the idea that within this singular gesture you create multiple perceptions, but also that what was important to us was, the shape, of course, but also the void that is created and the varying relationships across the void. So the next three projects, I'd like to focus on our kind of obsession with the link between material and conceptual economy. And this is kind of, in all of our projects, but mainly in these next three projects. We always try to overcome this divide between conceptually driven and tectonically driven projects. And we are not so much interested in minimalism, but we are interested in achieving a maximum effect with a minimum of means. Sometimes this is quite simply a matter of budget, but we often limit the number of disparate systems in our projects in order to do more with less. So this is our 2004 Young Architects project. It's the competition for the warm-up space at PS1, which is the Contemporary Art Center in Queens. It's kind of the cool sister to the MoMA in Manhattan. And it's an old public school, actually. PS stands for public school. So it's an old public school. It's a museum. In the summer, it's this kind of oasis for people who can't afford to go to the Hamptons. So there's a lot of cultural identities to unpack and to address. This is the courtyard site, and what is very special about this this site is that when you enter into the courtyard, all the kind of sounds of the city are dimmed, and all of a sudden your focus is on the sky. And so we wanted to simply connect the sky to the ground with what we called a deep landscape, and also to kind of counteract this bleak gray gravel and gray concrete of the courtyard by introducing some color. So the term canopy refers to the upper regions of the tree, but it also refers to the cloud coverage in the sky. And we started to think about how we could create very distinct environments that would provoke different modes of lounging. And so this is what this diagram is about. Every environment has a different saturation point of water, a different scale, and a different sense of lounging. This is actually the plan that we did after the fact, when we, after we had to introduce these two little blips. But you can kind of see the radiating grid. And then this is looking from the entry into the museum. We looked a lot at Fry Otto's work and were very influenced by it. We wanted to avoid the catenary. And early on in the process, we online met a bamboo consultant who told us about a certain species that was flexible if it was green. So this is 3 poles strung together, and it is very, very flexible. 3 20-foot long poles. That year, it was actually the first year that they invited landscape architects to also submit, and because it was coinciding with a landscape show at MoMA. And so we wanted to address themes that are typically within the domain of landscape architecture in our project. So the green bamboo was supposed to turn tan, pale yellow, by the end of the summer. In fact, this was actually July rather than August. It happened a lot sooner than we thought. And you can kind of see in this image, basically the thicker poles and the vertical orientation stayed greener longer. The ones that are horizontal and thinner became yellow faster. And so this photo was taken at the end of the summer, where it is really quite brittle and bone dry. Another idea of the canopy was to create a kind of variation of shade and shadow by pinching this grid. And so there are different densities of shadow across the courtyard throughout the day. And these are, on the left, are diagrams that we did where, and this is kind of alluding to the idea of shifting to the idea of amenities rather than program. We kind of thought through the cultural identities of this museum, thought about the different users, wanted it to make sense for all the different users. So, you know, and we use these different users in order to explain kind of how we organize the courtyard. So the barfly is only interested in where he can sit. The beach bunny is interested in the sunny areas, etc. You might recognize somebody from the audience in these photos. Matt Hutchinson worked on this project. We spent 6 weeks testing in the courtyard. We tested all of the details, the small spans, the large spans, the base connections, the top connections, and we went back to our drawings because we realized that the 3D model that we had submitted was too flat, and we needed to basically inject air and just kind of, you know, bump up all of the arches to increase the strength of all the spans. And then we also looked at these kind of critical moments of potential breakage in the bamboo, because through our testing we realized what the minimum bending radius was. And this was all trial and error. We did work with this fantastic guy, but you know, he normally builds bamboo fences, so it wasn't exactly his expertise either, and we just kind of, you know, tested everything. This is the steel that arrived first, and the bamboo arriving from Dudley, Georgia, 1,100 poles of Philostachys aurea. That were all kind of organized according to diameter. They varied, but they're basically about 1.5 inches at the base, and then they taper up to 1/4 inch, 1/8 inch at the top. We had to water them, keep them green and supple. And these are the basic splice types. So the structural ones went in first, which are the first two, the ones that actually hit a base ring or hit a top ring, and then the non-structural ones go in after. This is the cleaned up diagram. It wasn't that clean when we worked on it. And then this is an example of the drawings that the crew built the project from. So each grid line is translated into a 2-dimensional drawing with all the intersections marked out. These are the typical connections. And this is the process. Each grid line is laid out with the exact length, all the intersections marked, fit in temporarily at the top and into the ring beams in the bottom. And then the non-structural members across the top. It was a very interdependent, very indeterminate structure because you couldn't kind of do all of the structural ones and then all of the non-structural ones. You kind of had to build it in areas in a kind of egg crate fashion and then expand those areas, which is what this sequence is diagramming. And again, some more examples of the drawings that we used on site. So the red would be the grid lines that were going in next, and the gray is what is already there. So it's a very kind of elaborate organization of how the thing goes in. And then this is a view, and you can see kind of all the zip ties that are there. This is another element, the pool, which was made out of foam and then sprayed with polyurea. It was kind of an underwater furniture piece. And then the pads were actually built out of cedar decking, and the sides were painted with road paint so that the light from the underside would glow at night. And then in the smallest room, we planted the same species of bamboo. So during the summer, while the bamboo outside was turning brittle and tan and drying, the bamboo inside, what we call the rainforest, was growing and growing and growing like a weed. And then slowly, all the zip ties were replaced with stainless steel wire, because it was very important to us that the kind of third world associations of bamboo were not there in the final product. We wanted it to look very precise and very engineered. And so these are the 3,000 somewhat nodes that were replaced with stainless steel wire. And this is one of the Saturday crowds. It could swell to 7,000 or 8,000, and during the week the number is much, much less than that. So for us, it was very important to do a project that made sense for a crowd of 1 and a crowd of 8,000 at the same time. We wanted it to register. This is the pool pad that you see, and then on the left, the dry environment, the sand hump, and then here, one of the two small little dips in the canopy that we introduced just before the opening, because we realized that we could not do that span. We could not span from here to there, and so we introduced two new dips in the project, which I think made it better. This is the fog pad, and this is early on in the summer, so when it was dry, when the weather was dry, the fog would kind of dissipate almost immediately. Later in the summer, it became much thicker. So right after Canopy, we received a commission to do a 7-story condo building in the Lower East Side, right around the corner from our office. It was really a stroke of luck. The client, who you see on the left, walked in off the street and said, "I have a building. I have a building, and I want a stainless steel facade, and I need an architect." So we said, "We're your guys." But it was a little bit backwards. He had already dug this pit, and he was ready to place the elevator core. So, can you help me? So we designed it in 3 weeks, basically. It's very simple. It works within the developer logic of economy and repetition, and our challenge to ourselves was to create as much variety and difference as possible within the economic model of repetition. So the idea of switching refers to switching of views, switching of light conditions, for us it was very important to, considering that the Lower East Side was really rapidly gentrifying at that time, And there were a lot of projects such as Shumi's Tower in blue in the back that were capitalizing on this setback regulation where if you set back far enough, you can go taller. We really wanted to maintain a very strong connection to the street. And so the idea of the switching facade is literally the inhabitants occupying the skin. It is a piece of furniture, basically, on the inside. It's a bench. So when the developer approached us, he came up with a very typical kind of wish list of bay windows, balconies, blah, blah, blah. And we really wanted to take these and not make them separate attributes of the facade, but to really create a singular conceptual idea out of it. So we looked at a lot of bay windows from the very small to the very bizarre in the area. And we tried to take that and create a singular gesture out of it. So you see, and the other thing was that we really wanted to do something with those air conditioning grills that are ubiquitous in these kind of developer buildings, and to really incorporate it into the tectonic of the facade. So another survey of. This is interesting because this is actually not anything. It's almost like it's anticipating an air conditioning grill. So the switching is an idea at the urban massing level, but it's also an idea at the facade level. So over the air conditioning grills, the skin kind of peels, not peels, but it goes from flat to perpendicular to the air conditioning units, back to flat again. And then the cladding also switches. So on one floor, the panels will be oriented this way, and then the second floor, it'll be oriented the opposite way. So from the outside as well, the light and shadow effects are quite different from one approach versus the other. And these are some construction drawings. This is of that particular moment over the air conditioning grill. And one of the prototypes sitting. And you can see in this image the different light and shadow effect from floor to floor. And then from the inside, this kind of facade, piece of furniture facade. So we thought it'd be fun to, in New York to force some neighborly interaction. So we switched the balconies as well to, force some communication. And it actually does work. The people are very close in this building. So this is a typical two-bedroom floor plan. The plan is the same. The switching of the bay window in the front and the balcony in the back produces very different light and views from the inside. The facade is galvalume, not stainless steel, a lot cheaper. And the balconies that you're looking at, the glass is actually a green stripe on the glass, so a little bit of color, but you can still see through it. And then on the street level, it's basically split between the residential lobby and then the gallery, and the whole facade opens up. And you can see in this plan, this is the gallery space. It's a double height space. When we started working on this project, there were a couple of galleries opening in the area, and now that it's actually quite an important gallery district. And we really argued to have this double height space because unlike Soho and unlike Chelsea, the galleries in this area are really small because they're generally housed in these tenement buildings. This is a view looking to that double height space in the gallery. The sawtoothing of the ceiling is basically the same. It's a material called Versarock. It's the same material as the sheathing behind the galvalume of the exterior. So it's as if that's kind of coming in and wrapping on the underside. And then this is the residential lobby. It's very, very tight. So we used a visually rich and very warm and kind of busy material. It's plywood on end. And the penthouse, and the best view is from the bathroom. This is a project that is in our office right now. It's for ABC, which is basically Macy's in Lebanon. It's the oldest department store in Lebanon. It is here. It's in the northern part of the city. It's on the main north-south highway, and it overlooks the Mediterranean. This is the existing building, so it's not too hard to come up with something a little better than this. But so we are working with an existing building, and we're recladding the facade and obviously giving the store a new identity. So given the location on the highway and given the kind of car culture on that site, we started thinking about these highway billboard signs, playing with that. This was an early option that we didn't go with. This is their logo on the left. And so what we came up with was a lattice out of their logo where we varied the density and the gradient across the facade. This is actually an earlier model, and it's now much simpler. And we are in CDs right now. It's a 1 to 10 model in our office, testing the light condition, testing the aperture size. And this is the most recent version. So the gradient is much more simple now. It basically diminishes in porosity either towards the bottom or towards the top, depending on where you are. So each facade, that gradient orientation and direction is changing. So as you wrap around the building, the kind of the weight of the light is in a different place. The third idea that I'm going to talk about is this idea of climate as strategy. Climate as a catalyst for how one organizes the building, basically how can climate shape the very morphology of the building. Maybe it's because I've been procrastinating my lead exam, but we're very suspicious of this kind of checklist mentality in terms of sustainability, kind of filling in all the particular requirements, and we're really trying to look at climate as a conceptual driver at the very beginning of the project. So this is a competition that we were invited for. They stage these competitions every year. It's by an organization called Living Steel, and it's always in different cities every year. But the brief is to design innovative high density, low income housing using steel in a sustainable and innovative way. So our location that year was in Wuhan, China, which is one of the 4 furnaces of China. It's extremely hot, tropical almost climate. And we were interested in, and the kind of the massing was given to us in a way. So within these constraints, we were working with an idea of creating variation in typology that would connect to an idea of demographics. So we created a house type and a very flat kind of apartment type that would, where the floor-to-floor height changes as you go up. They're higher on the bottom, and they are lower. The floor-to-floor height is lower up above. Essentially, the volume of each apartment is the same throughout. So in a way, trying to erase the discrepancy of the most desirable unit on the top versus the least desirable on the bottom. So this is the south facade, which is a actually single loaded corridor. The south facade is a single loaded corridor, and the facade is made up of SIPs, structurally insulated panels, and this is the facade. So all of the wet functions are arranged along this facade, and within this facade, it also collects the rainwater for gray water use. So this is a diagram of the kind of, the consistency in volume of apartment as the actual proportions change as you move up. So basically the idea was, typically in housing, it often becomes a kind of puzzle or a kind of, game of combining as many different units as possible in a very intricate kind of three-dimensional puzzle. For us, we saw it as a card game, where we thought if we could just free up the plumbing, which unfortunately dictates a lot of housing, you could actually stack any of the floors any way you wanted to. So the idea was that each developer could take the plans and rearrange the floors like a game of cards, however the market demanded. So you could decide how many of the townhouse units versus how many of the apartment units you needed, because the structure was simply in the north facade and in the south facade, and all of the spanning walls in between were non-structural. So those were very flexible. The left is the north facade, which, unlike the south, is just trying to direct ambient light in, and you can really see the progression of the apartment heights in that facade. So the next project is maybe the most literal illustration of this idea of climate as concept. We were commissioned by the Savannah College of Art and Design to design an installation. It was actually an art commission, but we're not artists, so we said we would do an almost architecture installation. We did 2 pavilions that change with the wind. We designed it before visiting the site. And so from our research, we found 2 things. One, that the town of Lacoste is actually where the Marquis de Sade escaped to when they kicked him out of Paris. And his castle is right behind our site. And so we thought that would be very important, but it was not. The second thing was that the area of France, it's in the south of France, near Provence, has a very, very strong wind called the Mistral. And in the past, crimes of passion were excused during the Mistral. So that became important. So this is the site. It is an incredible landscape of these small little hill towns, seemingly hewn out of the same limestone, overlooking this incredible billowy, swaying landscape of olive trees and cherry trees. And so, quite simply, we wanted to somehow blend the hard and the soft. We wanted to, in a way, speak to the angular geometry of the stone and try to reflect the dynamic behavior of the landscape around it. So this is the site plan of the 2 pavilions. We sited it at the gate, at the old fortress gate. In our minds, it was almost as if we were creating a fictional extension of those fortress walls, but inverting the heavy masonry logic and replacing it with something much more light and much more ephemeral. So for us, there are several ways to deal with the wind. One is to let it pass. The other is to absolutely block it. We wanted to do something in between. So we wanted to do something that would register the wind, register the different strengths of the wind, and reflect it in a constantly mutating shape. So this is what it's made out of. It's plastic pipe and string, very cheap polypropylene string. what was critical in this project was the really thinking about the construction sequence, because if you've ever tried to find a screw or a screwdriver in the south of France, you know what I'm talking about. It's they were all on vacation all the time. So we really had to think about a very base kind of construction logic. So it's all predicated on these triangular tripods that are staggered to make up this thick masonry, the thick inverted masonry wall. So this is the sequence. Each pipe is drilled and stitched in a kind of primary stitch. The lower tripods are set up. And then the upper ones, pre-strung, are put into place, loose, because we needed it to be quite flexible. It was, we were not there, so all the kind of discrepancies of the site condition really changed everything. So it was quite difficult because the abstraction of our 3D model was not the reality. But anyway, these are the upper ones. And then the upper ones are strung together, the webs are put into place, and then repeated, the inner layer. And a lot of this came from us looking at our canopy structure, and at this one location in our canopy structure during a windstorm that was kind of flapping in the wind, and we thought that'd be fun to build a structure that specifically responds with the wind. It was even more indeterminate than canopy. We actually never structurally modeled it. We built half of it in New York, but we had a lot of testing to do on site. So what happened between day and night was, in the evening we had some light fixtures in the base. In the evening the light really picked up the string, and so you felt much more of a sense of enclosure. In the day, the string almost disappears and kind of disappears against the grain of the agricultural fields in the distance. Villa Villa is a project that we think will be built. We're not sure. There are different phases to this project, and the first phase has started construction. It's a house in Inner Mongolia, China. It was the client is a developer who, among other things, made his money on milk, Mongol milk, if you've ever heard of that. Not one of the tainted ones, but. And so this is some pictures from the site. It's a very harsh climate. The annual temperature is -5 Celsius. This was important. The fact that it was very far away and needed to be of a certain very tight budget was also important. So we designed a house within a house, an inner house, which was what you need, and the outer house, which is what you want. The inner house is the compact house, and that is the fully conditioned house, and the outer house is the spillover space during more temperate conditions. So on the left is the typical installation diagram. On the right is Villa Villa. So the two layers are insulated. The outer one protects the inner one. Basically, we realized when we visited it that this idea of hanging out on your porch just wouldn't work in Inner Mongolia. So we tried to create an exterior feeling space within the house. So these are the 3 floors of the house. And in this model, you can kind of understand the relationship between the inner house and the outer house. The outer house is this kind of spillover space. The inner house is horizontally stacked. And each floor has a very different connection to the landscape. So this is the first floor, garage, guest bedroom, each with their own particular orientation. And this is the plan. So this is the entry. You enter into the outer house, and then you go into the inner house. So what you see in white is the inner house. The second floor is a donut, basically. It's a totally open space with all the living space, the kitchen, living, dining area, each with their own orientation again. And you can see in this plan, so this is the inner house. This little bit is the ceiling of the first floor. And so that is part of the outer house. And then lastly, the bedrooms. North, south, east, west, each one with their own particular orientation. And then again, in the plan, you can see this is the inner house and this is the outer house. So really the idea of the layering for us was a way to respond to the extreme temperature swings of the desert climate, but also to be much more efficient about where we put money in materials, where we put money in terms of all the more fine detailing, and where we can be rougher and cheaper. Essentially what we were trying to do with the 3 floors was to create as much variability as possible between the 3 floors, but structurally make it as simple as possible. So this is the structural plan. The red is the 3rd floor, the blue is the 2nd, the gray is the 1st, and you can see that each of the floors is basically spanning from one of these columns in the middle to the perimeter wall. And this would not have been possible without parametric modeling. And we used it in a very simple way, but because of the budget and because of the distance of this project, knowing that we couldn't walk around the block and control this project, we were searching for what to standardize, what to make simple. And in the beginning, we thought that it was very important to standardize all the windows, but eventually we relinquished this and understood that it was more important to make the structural logic really simple and minimal. So this is part of the CD set. So you can, this is the structural sheet where you can see the 4 columns and then the perimeter wall that also acts as a shear wall on the outside. And then these are sections cutting through. You can kind of get the sense of the inner versus the outer. These are sections that are cut just behind the facade, so everything in white is the inner and the hatching is the inside facade of the outer house. And this is a diagram of basically 2 main mechanical zones, the fully conditioned one and then the partially conditioned one. And the idea was that in the very extreme heat of the summer and the very extreme cold of the winter, you would retreat into the inner core. And in the more temperate seasons, you could passively heat or passively cool the outer house by opening up the sliding partitions that close the inner from the outer. So this is a view of that 2nd floor of the living space that is a donut. And it's these kinds of views that we were really interested in, this kind of view to the outer house and then the view to the outside, this kind of layering of the different thermal zones. And then a view of the outer house and the inner house at the same time. So the inner house is where we put all the money. It's where the materials are. It's much more warm. It's much more polished. The outer house uses a very typical Chinese construction, which is just the red brick painted white. So the outer house, in contrast, is white, abstract, and rough. And the lighting only comes from the top, whereas the inner house, the lighting is only from the side. So this oscillation between fully conditioned, partially conditioned, side light versus top light, warm materials versus abstract white, it was something that we were interested in. And just the idea of living could expand and contract throughout the year. This is actually the view when you enter, looking up. So we actually built an enormous model of this for the Seoul Design Olympiad, which is Seoul's version of the Venice Biennale, except for they do it every year. And we worked with Arup on this. We wanted to do a thermal mapping model to explain the thermal logics of the project. So these are Arup's models that they did, analyzing the different temperatures of these different zones. And then this is the model. The scale was 1 to 7.5, roughly. And so in the model, we replaced the brick walls with glass, and we covered all the surfaces with a grid of temperature dots, indicating the temperature in the extreme cold. So the blue on the outside is really, really cold. The green that you see is within the outer house. That's something in between. And then the red is indicating the fully conditioned, heated environment of the inner house. This is very, very recent. Actually, this is the last project. We just finished this. This is New Aqueous City. It is a speculative project for an exhibition at MoMA that is opening March 23rd, if you're in town. MoMA is taking a huge risk with this exhibition because they organized the exhibition before they knew what the content was going to be. Basically, for the last 2.5 months, 5 teams, the 5th one is working on southern Manhattan. 5 teams have been at PS1 in a kind of professional residency, proposing futuristic, provocative yet real projects about the Bay, about Palisades Bay, that deal with the issue of the rising sea level and the increased frequency of storm surges in the future. So we are each dealing with a different site. Ours is this one. This is the Verrazano Bridge. This is Brooklyn, Staten Island, New Jersey, southern tip of Manhattan. So the way this started actually with a book, with a research that Guy Norensen, the structural engineer, and Adam Urinsky from Aero and Catherine Civet did, looking at New York and looking at this problem of rising sea levels and trying to find an answer that is not hard engineering, that is a kind of counterpoint to the typical storm surge barrier proposals that are out there. And just trying to find opportunities for architecture and landscape architecture. So this is our site. It is defined by Sunset Park and Bay Ridge. This is the bridge, and Staten Island to the west. And out of the 5 sites is kind of the largest in area, and it is the most varied in terms of social, physical, and economic conditions. And so for us, the interest in the project was not to, it's such a huge problem. For us, it was, we approached it not as a design, a specific design of a specific area, but more trying to show a window onto how a city might grow in the near future as well as the distant future in order to adapt to our soon-to-be very aqueous condition in New York. So the blue shows the 20-foot inundation zone, which is what would be flooded in a Category 3 storm in New York. And so our challenge was to, propose design solutions that would accept this new aqueous condition, and B, for us to reimagine urban living in this new aqueous city. So this is the residential use maps and the industrial. So quite obviously, we wanted to bridge the divide between land and water. We wanted to bring land onto water and water onto land. And secondly, we were interested in the idea of dispersed infrastructure, not to put a hard line out there, but to create a more acupunctural approach of points rather than lines that could grow and create habitat around our interventions. So this is I'm not going to go through everything in the project, but this is a plan of our project. I want to focus on three aspects of the project, moving from land to water in terms of three different resilient strategies that are very interdependent. The first is a series of islands and barriers. The second are these piers that also serve as ferry stations. And the third is a new aqueous building typology. So this is actually a storm surge barrier that is being proposed. This is our site. This is the Verrazano Bridge. And this is very similar to the one that is in the Thames, and also very similar to the one that is in that is in Zeeland, in Holland. The problem with this is that it really constricts the flow of the river. The bay actually flushes out twice a day, diurnally. And so anything that is always there in terms of a proposal is bound to harm the ecological balance of the bay. So does a barrier have to look like that, or could it look like this? We actually proposed to create islands that could act as a barrier when we need it to be there. And the technology does exist. It's actually implemented in 200 different locations. And so what we were proposing is a series of islands with dynamic inflatable barriers that are deployed in a storm surge and otherwise disappear. So I'm showing you some bits of the exhibition, actually. This is one of the animations in the exhibition. So this is the idea of the islands, and this is the inflatable barrier deploying. And what it would do would basically be to hold the water at bay on one side and to break the wave energy. But more importantly, the idea is that 99.9% of the time, what is actually there are islands, natural habitats. So for us, the idea of the solution to this problem of rising sea level is not to see it as an engineering solution solely, but to look at engineering or rather to merge engineering with landscape. So we were quite fascinated with this idea of proposing hard solutions that eventually accrete sediment and sponsor natural habitat over time. So this is part of one of the panels in the exhibition. Moving from left to right is what we're trying to show is this kind of temporal transformation of the hard engineering solution eventually accreting sediment from the down current and creating a natural habitat, sponsoring a natural habitat. The second aspect of the project are these series of piers that also double as wave breakers and ferry stops. And we imagine that the piers are part of this now very public waterfront. Typically in that area, it's very cut off because of industry. And we started to reimagine programs along the waterfront as mobile programs. So the idea would be that the pier, the wave breaking part of the pier, which is on the up current side, is fixed. On the down current side, it's actually floating, which also helps to break the waves, and all the program is floating. So, and there's examples of this in New York. There's the floating science barge. There was the floating swimming pool during the summer. So we imagine floating markets and floating libraries and these kinds of mobile programs activating the waterfront. And the last aspect that we looked at was the residential neighborhoods or the mixed-use blocks. So if one typically builds very sensibly from a shared street up in the city, in New Aqueous City you build from a shared roof down. So the shared roof goes in first, and then the houses go in, and basically the more risk you are willing to take, the lower you hang your house, which actually has precedent in terms of how FEMA works and how the national insurance worked in New Orleans and other floodplains, where they will only insure up to a certain floodplain. So it's putting that on its head in a way. So again, a little slice of one of our panels showing the aqueous building typology, and this idea of a floating treatment wetland where the waste from the mixed-use blocks would be treated through these floating treatment wetlands. So the dry waste is treated inside, the wet waste goes through an anaerobic digester and then flows down these floating modular wetlands, eventually discharging clean water and not smelly water into the river. So to wrap up, since 2000 we've tried to address a wide range of scales in our work, from buildings to interiors to installations, and more recently the urban scale. Regardless of scale, the questions that we're always asking try to go beyond the conventions of program, type, and context. We are not so concerned about aesthetic or formal consistency. We're much more concerned about whether we're asking the right questions and whether we're framing the problem correctly. And basically the same range of scales are in the current projects that we have in the office right now. The ABC department store, this maintenance and repair shop for the Department of Transportation, and a 3,300-foot-long linear park in Buffalo, New York. And I just wanted to finish with the dismantling of canopy. We sold it to Matthew Barney, who wanted bamboo for his then latest movie set. And we just needed to make some money, so we told him, yeah, it'll be straight when you dismantle it. But really, we were not sure what would happen because it had been up for 5 months, conformed to this very precise geometry, and we just kind of gave them a sketch and said, you know, cut here. The fascinating thing is that as soon as the pieces hit the ground, they flattened immediately. So what, in fact, are we really in control of? The way in which we formulate the design problem, hopefully, scaling and situating our ambition for each project, and a critical leveraging of our production tools. The list of what controls us and our work is too long and boring to get into. Somewhere in between are the moments where we happily relinquish control, as in the multiple interpretations and misuses of our environment, the varying relationships between our work and its environment or its inhabitants, and the productive influence of fluctuating external conditions. This is ultimately where we try to aim our efforts. Thank you. Yes, there are the concept, quite simply, was to take their logo and make it into the facade, and to create a varying aperture so that the kind of the big boxness of the building is seemingly reduced, because it is quite a whale on the site, by varying the gradient and the direction of the gradient as you move around the building. yes, the lights will have color. Hopefully, we will be able to control the kind of color, but I doubt it.
I have a question regarding you, like a pyramid museum. Like you put a lot of thought on how people get into the museum, how people circulate the museum. You have the airport, like analog. So I just don't know, how do you think about your building with the pyramid itself? So pyramid has been up for a long time, and now you bring in this building. How does the building relate to the pyramid?
We've conceived of it as a viewing platform and as a framing device in many scales. So the arrival is an exterior plateau that is a shaded 300-meter-long plateau that is directly looking to the pyramids. They're maybe half a mile away. And then within the building, where the floors dip down, also offer views to the building, to the pyramids. So for us, it was, you know, a kind of a viewing device, kind of portal that would, in a way, physically physically connect, not physically, visually connect to the pyramids beyond. Formally, I'm not sure, you know, what consciously. I mean, of course, we were, you know, had lots of, you know, cockamamie geometric, half-baked relationships, but none of those are really important ultimately. They're there, but it's too embarrassing to get into.
How would people perceive, like from outside your building? You're talking about from your building to look at the pyramid. How about what people would feel when people are looking at your building from the pyramid?
I'm not sure. Well, it would be very simple. What they would see is, what they would see is a floating bar that just hovers above the desert, which we liked in contrast to the heaviness of the pyramids.
I have a question for you. Budget seems to play a big role in architecture, especially your projects. Why is this so? And can you maybe approach people with a lot more money that might affect?
If anyone has the answer to that, I want to talk to you. I think no matter what your budget is, you have to be responsible to the budget. So I can't say that we've, you know, had total freedom. We have had very low budget projects, and we've had decent budget projects. It doesn't really matter what the budget is. Ultimately, I think you need to be very strategic about how you spend that money, whether you spread it or whether you really hone in on what you want to invent, and you know, balance that with more conventional modes of building or more conventional materials in order to in order to ultimately have a project with a strong concept. So, and there's no, I think that there's no right answer, but for us, it's about knowing how to tailor the ambition. So knowing where to invest in invention and knowing when to pull back. So for example, in the China project, it's quite abstract for us, the issue of budget, but they did give us a very good sense of what that buys in China. So, you know, they said, this is your budget, and this is a building within that budget. So, you know, we knew from the start that it could get us slightly nicer brick, but it's not going to get us, a very sophisticated, geometry. So we accepted from the beginning to use traditional Chinese brick and to use and to incorporate the way that they typically use that brick, which is concrete frame and infilling that brick and painting it on the inside, but combining it in an innovative way.
I'm curious to know a little bit more about your project in New York with the rising sea levels.
Mm-hmm.
Typically, when you see a dam or a levee, it's follows the shape of the land, or if it's an inlet, it's a linear line that cuts it off. But with your islands, it was a much more kind of complex geometry. I noticed a lot of sharp angles. Can you talk about how you, where you chose placement of the islands, or how those geometries react to currents, or?
Mm-hmm. There are a couple of things. The sharp angles. We were playing with a kind of modular geometry that could be built. I mean, in this project, we're kind of striking a balance between being futuristic and provocative, but at the same time somewhat realistic. So the geometry is just simply based on a module that can be combined and in different ways and rotated in different ways in order to capture the sediment that is flowing from the down-current side. So the geometry is simply one that is able to collect sediment in the in its kind of acute angles. So the idea was that when it goes in, you really see that triangular geometry. Eventually, over time, what you see is a much more organic, softer core that forms on the outside. And then in terms of the location on the site, it is determined by the bathymetry, for one. So it wouldn't make sense to sink it into the very deep parts of the channel, also because we had to stay out of the shipping lanes. So we kind of chose a zone of -20 to -30 to drop the islands. And also the idea was that 99.9% of the time, when there isn't a storm surge, what you see is an archipelago of points of natural habitat, and what you see deployed during the storm surge is a defensive line. So we were trying to have our cake and eat it too. We wanted to have this kind of free, seemingly random array of islands that, when connected by the rubber barriers, create a defensive line. And for us, that was also part of the idea of the thinking about the layered strategies, because obviously any single line of defense is bound to fail. So for us, each strategy had to be resilient in and of itself.
About the Villa project, at what point did you decide that the structure was going to be something that you pursued parametrically? Was it at the building's conception, or was there a point where you're like, maybe we should start looking at parametrics now? And was it ultimately critical to the building structure?
It is. I think I don't think that we thought of it from the very beginning. And honestly, which software we use really depends on who's in the office. So, we're now at the point where, I'm just kind of giving up hope of ever getting my Rhino tutorial because I just don't have the time. So whoever is in the office, they're running the software. So we had a project architect who knew SolidWorks. So at some point we decided that the goal of creating very simple floor plates, but totally different from each other, was only going to work if we could make it very, very simple for them to build. So I guess to answer your last question, whether it's really critical to the structure itself, in the end, no. It's very critical to our process. But ultimately, we don't care whether it's legible. In fact, we don't want our software to be legible in the end product. We would like that to disappear ultimately in the end.
Thank you very much.
Thank you.